With all of that background, we're finally ready to do the lab.
Let's roll those dice.
The purpose of this lab is to do an experiment to see if math.random really generates numbers uniformly.
Generating random numbers uniformly is the mathy way to say that every value is equally likely.
To do that, we're going to generate lots of values and count how many times each occurs. In the end, all of the values should have happened about the same number of times. Essentially, we are rolling a six-sided die thousands of times and making sure that every side is equally likely. In the end, they won't have rolled the exact same number of times.
There is a random effect when you roll a die.
But there shouldn't be one side that happens a lot more times than any of the others. The information that the experiment needs to track is how many times each side of the dice was rolled. To do that, we use an array named count that holds integers. There is one position in the array for each side of the dice. Every roll, we increment the position of the array that is associated with that roll's resulting side.
Pay close attention here. Each position of the array is a count of how many times one of our random values happens. It does not hold a random number. It holds counts.
When we start the lab, it's set up to generate integers from 1 to 6, like a normal dice. Since the dice has 6 sides, we are generating 6 possible random numbers, so our array needs to be able to hold 6 counts. In Java, all arrays start at position 0. That will hold the count of the minimum roll we can make, so the 0th position will hold the count of how many times we generated a 1. The next position will hold the count of how many times we generated a 2, and so on, up to position 5, which will hold the number of times we rolled a 6.
So, position I holds the count of how many times we rolled I plus 1, because 1 is our minimum value we can roll.
The lab stores the number it generated in a variable named rand, so it holds the roll of the die. The position associated with that roll is found by subtracting the minimum possible roll from the roll we got. Count sub position is how we access the position of the array, so we just need to increment that. We can do that either by adding a 1 or by using the increment operator. This lab is running an experiment to see whether math.random can be used to simulate a fair die. It does that by generating a random number that simulates a roll of the dice many times. The data that it gathers is a count of how many times each possible value happened, and it stores that data in an array named count. Each position in the count array keeps track of how many times one side of the dice gets rolled. The code then prints out a summary of what happened, and the user is left to judge whether the die is fair or not.
After we play with the normal 6-sided dice, we'll play with the constants to generate other possible ranges to make sure that the logic works for all kinds of dice.